Okay, so we're looking at 10.3, number 33. So that's this one here. We want the area of the region enclosed by the inner loop of the limacon, r equals 1 plus 2 cosine theta. And they even give us a little hint. They say the radius is negative over the interval of integration. Um, so I guess we should be looking for where this thing is negative. But to see why that is, I think it's helpful to draw a picture of the region, which you're supposed to do anyway. Um, I think that was one of the guidelines I gave you on doing problems like this, was to always sketch the region in question if you're not outright given a picture of it like this or something. So let's do that. Okay, so we've got r equals 1 plus 2 cosine theta. Just looking at it, I know that this is a limacon. I know that because this number is bigger than that one, that it's going to have an inner loop. And since it's a cosine limacon, it's going to open either left or right. When I say open, I mean like it's going to kind of bulge out either to the left or to the right. And since it's a plus, that means that it's actually going to bulge out to the right. So I can get a pretty decent looking sketch of it. Now the other thing to keep in mind is that the largest cosine can never be is 1, which means that the largest this thing can never be is 3. The smallest cosine can never be is -1, which means the smallest this thing can never be is 1 minus 2, which is a -1, right? So that kind of gives you the setup, I guess, because I know that like the widest that this is going to ever get out is over here at 3, and then the inner loop is going to happen when r is negative, and that's the largest it can ever be is at is -1. So that's going to it's going to be, cosine is going to be its largest when theta equals 0, right? That's when cosine is 1. So at theta equals 0, we're out at r equals 3. And then at theta equals pi, that's when cosine is -1. So we're at pi -1. So we end up at that point there. Anyway, so the rest is kind of history. I suppose you could say, well, what's cosine? What's going to happen when theta equals pi over 2? Well, cosine of pi over 2 is 0, right? So r is going to be 1. So we're there. Same thing at 3 pi over 2, right? It does sort of beg the question, like, it does sort of beg the question, when does this thing cross through right at 0? And we could solve this for 0 if we set 1 plus 2 cosine theta equal to 0. Then we would need for cosine theta to be -1/2. I know that cosine, sorry. Okay, I know that cosine is going to be 1/2 whenever theta is pi over 3. So cosine is going to be -1/2 at 2 pi over 3, right? So so when theta equals 2 pi over 3, that's when r should be 0. So and then it's going to happen again, of course, at theta equals 4 pi over 3, right? So these are the places where r is going to be 0, and therefore cross through the pole. So if you kind of imagine, like, here's 4 pi over 3, I guess. Ooh, that was not very nice, but and then, or sorry, 2 pi over 3 is there, 4 pi over 3 is maybe somewhere right here. So it's gonna kind of cross over like that, right? So I guess putting it all together, the thing looks like this. Then it crosses through, loops around, okay, and kind of goes like that. I think it probably gets a little fatter, because these things look a lot more beautiful than the way that I end up drawing them most of the time. But anyway, so that's the picture, and this is the region that we want. Well, we've already done, I think, the work of like finding the limits of integration, right? Because it seems like in order to get inside of this inner loop, That happens when we cross through the pole and then we're negative, right? So it happens, and we cross through the pole for the first time here at 2 pi over 3, right? We're crossing through the pole at 2 pi over 3, and we stay negative this whole time. So we're still kind of going around this entire inner loop until we get to 4 pi over 3. Then we're back at the pole, and we pop back out, right? So those are our limits of integration right there, right? They've got to be. So the area, I suppose, would be integral from 2 pi over 3 to 4 pi over 3 of 1/2 times r squared d theta. I don't know how difficult this thing is to integrate, but I'm going to assume that probably the difficulty was setting it up. And in fact, I think 2 of you asked this question, if I'm not mistaken. So I think Sylvester asked this question, and then I think Jordan also asked for number 33. And he says, for number 33, I knew how to do all the integral work. Okay, yeah, so you know how to do the integration. I'm just having trouble on visualizing the bounds. Yeah, exactly. That is the hard part, right? Visualizing the bounds on polar graphs is definitely kind of the new trick that you have to learn. But hopefully this video makes it clear why these would be your limits of integration, right? 2 pi over 3 to 4 pi over 3. I think that's all I'm going to say about it then. So that's that one.